Hello all, this is Dr. A. Anuja, Assistant Professor, Department of Mathematics, Arulmigu Palani Andavar Arts College for Women, Palani. In this lecture, we are going to discuss about one example for the Unit 1. The example is the resultant of two forces PQ acting at a certain angle, its x, and that of P R acting at the same angle is also x. So the resultant of Q and R again acting at the same angle is y. So we have to prove P is equal to x square plus QR the whole power 1 by 2 is equal to QR of Q plus R divided by Q square plus R square minus y square. And also we have to prove if P plus Q plus R is equal to 0, and we have proved y is equal to x. So the solution is, first we have to assume P and Q are forces, those are acting at an angle alpha, and from the given statement we have the following result. So first we forming x squared is equal to P squared plus Q squared plus 2PQ cos alpha, mark it as equation number 1, and x squared is equal to P squared plus R squared plus 2PR cos alpha. This is equation number 2. And the third one, y squared is equal to Q squared plus R squared plus 2QR cos alpha. Now we have to subtract equations 1 and 2. So that is x squared, the left hand side is x squared minus x squared is equal to, and what are the right hand side is P squared plus Q squared plus 2PQ cos alpha for the equation 1, and minus, we taking minus for 3 terms, minus P squared minus R squared and minus 2PR cos alpha. So we subtracting these left equations, will get left side as in 0, and the right side we cancelling the p's, because p has both are different signs, so we cancelling p squared and will get remaining as Q squared minus R square and plus 2PQ cos alpha minus 2PR cos alpha. And the next one, we are taking the 2PQ is a common, so we write 0 is equal to Q squared minus R squared plus 2P cos alpha, and we'll take Q minus R as common. So we'll get 0 is equal to, we expand or we applying the formula a squared minus b squared is equal to a plus b into a minus b. So for this we are applying Q squared minus R squared as Q plus R into Q minus R plus 2p cos alpha of Q minus R. Then in two terms we have a Q minus R is common, so take it in outside. So we'll get 0 is equal to Q minus R into Q plus R plus 2p cos alpha. But here we are saying Q and R not equal, but Q minus R, those are all not equal to 0. So we are substituting these results. So we'll get Q plus R plus 2P cos alpha is equal to 0, because previous equations will get 0 is equal to Q minus R into this term. So in this case, we'll say Q minus R is not equal to 0. So obviously the term Q plus R plus 2P is also equal to 0. So that's why we'll get the second term Q plus alpha plus 2P cos alpha is equal to 0. So we are keeping 2P cos alpha as on left side, and we'll take Q and R as on right side. So the signs are changed. So 2P cos alpha is equal to minus of Q plus R. So we'll get cos alpha, take 2p as on right side. So here 2p is in the form of multiplication. If we take 2p as on right side, it will transfer into the dividend. So minus q plus r divided by 2p. So this is equation number 4. Now we are substituting equation 4 in equation 1. So we'll get x squared is equal to P squared plus Q squared plus 2PQ. For the cos alpha, we are substituting minus of Q plus R divided by 2P. So we'll get x squared is equal to P squared plus Q squared minus, we are cancelling 2P and 2P. So we'll get Q into minus Q plus R. For this we'll get a minus Q squared and minus QR. So we are cancelling Q squared and we'll get x squared is equal to P squared minus QR. So the finally we want p squared. So we'll keep p squared as on left side and remaining take it in the right side. So we'll get p squared is equal to x squared plus qr. So we are cancelling, we are taking square on both sides. We'll get p is equal to x squared plus qr of 1 by 2. So first one is proved, and the next one we'll substitute the equation 4 in equation 3. So we'll find y value. So we are substituting the equation 4 in 3. We'll get y squared is equal to q squared plus r squared plus 2qr into, we'll substituting the cos value. So we'll get y squared is equal to q squared plus r squared minus q squared r divided by p minus q r squared divided by p. So we are taking LCM for the right side. So we'll get the right side convert into pq squared plus pr squared minus qr squared minus q squared r whole divided by p. So we'll take p is on left side. So we'll get p into y squared is equal to pq squared plus pr squared minus q squared r minus qr squared. So we are taking p is uncommon, so we'll get p of y squared minus q squared minus r squared is equal to minus qr into q plus r. So therefore we taking q squared minus y squared minus r squared is on right side, so it will convert into division. So p is equal to qr of q plus r divided by r squared plus q squared minus y squared. This is the value for the p when we are applying into the y equation. So we'll get a equation, the proved 1 and 2. The next one we have to prove for the sum of three forces equal to 0. But we know q plus r is equal to minus p. So we are taking minus p is on left side. So we'll get plus p plus q and plus r is equal to 0. Now then we are substituting the equation 4. Cos alpha is equal to minus q plus r divided by 2p is equal to, so we know q plus r is equal to minus p. So we are substituting this, we'll get minus into minus plus divided by 2p is equal to p by 2p is equal to, we are cancelling p, we'll get 1 by 2. So therefore cos alpha is equal to 1 by 2. Put cos alpha is equal to 1 by 2 in equation 2 and 3. So we have x squared equal to p squared plus r squared plus pr, equation number 5, and y squared is equal to q squared plus r squared plus qr, this is equation number 6. Now we have to subtract these two equations 5 and 6. So we'll get x squared minus y squared is equal to p squared minus q squared plus pr minus qr. Now we are applying the formula a squared minus p squared instant to p squared minus q squared. So we'll get p plus q into p minus q plus r of p minus q. So therefore we'll get x squared minus y squared is equal to p minus q into, so sum of the three forces equal to 0. So we are applying p plus q plus r is equal to 0. So we'll get 0 of p minus q. So anything is multiple or divided with 0 will get 0. So the x squared minus y squared is equal to 0. So we'll take minus y squared as on right side, it convert as a plus. So x squared is equal to y squared. So we are cancelling the square, we'll get x is equal to y. So hence we proved. Thank you.